Hey everyone, and welcome back to English BookCast. You know, we always love it when you guys participate and get involved, so if you're digging these deep dives, think about sharing them around. It really does help get the word out, and we appreciate it. And hey, while you're at it, might as well hit that subscribe button too, right?
It's awesome to have such a curious audience tuning in week after week. And, speaking of things that pique our curiosity, today's topic was actually suggested by one of you listeners. It's U.S. Patent 5,625,241.
Yeah, that's right. Carousel electric generator. Catchy title, right? But this patent's about way more than just a name. We're talking a totally new design for an electric generator, and get this, it can also work as a motor. Our listener who sent this in really wanted to get a handle on the core ideas here, the real meat of the invention and what kind of possibilities it opens up. And that's what we do here on the deep dive, break down complex stuff into those aha moments. So, ready to take a spin on this carousel electric generator.
Let's do it. The patent starts by laying out the need for this kind of tech. It talks about how there's so many uses for small generators, the kind that produce a kilowatt or even less. Think backup power for emergency lights, off-grid living, or even something for your RV or boat.
Totally. And the thing is, these generators might sit around for ages, maybe not even getting much maintenance. Then, bam, the power goes out and someone who's not an electrician needs to get it running. So you really need something reliable and easy to use, right?
Absolutely. The patent really stresses how important it is to ditch those finicky parts that tend to break down, like batteries or other power sources, just to get the generator going. Fewer things to go wrong means a higher chance it'll work when you need it most, especially if you're not a tech whiz.
Makes sense. And then there's the size factor. When you're talking portable stuff, like for a boat, you want the most power you can get in a small package. The patent even mentions maximizing power per unit volume, so they were definitely thinking small.
Yeah, and that focus on shrinking things down makes you wonder what was happening back in 1997 when this patent was filed. Was it the boom in portable electronics? Or maybe the growing interest in off-grid lifestyles? It'd be interesting to dig deeper into the context. But getting back to the invention itself, they're building on the idea of permanent magnet generators, or magnetos.
Right, magnetos. Now that sounds like old school tech to me. Does the patent touch on that at all?
It does. It gives a nod to the history of magnetos, going all the way back to those early spark plugs in cars and airplanes.
Yeah.
Even the first telephones used them for the ringing current. And get this, the Model T Ford used one for its headlights. So yeah, it's a tech with some serious history behind it.
Okay, so we have this foundation of magnetotechnology, but what makes this carousel electric generator different? What's the big innovation here?
The patent makes it crystal clear it's all about the structure. It's the way they arrange those permanent magnets in the electrical windings that allows for crazy high speeds and frequencies, which, like we talked about, is how you get so much power in such a small package. It's not just about using magnets, it's about how you arrange them to make magic happen.
So it's not just tricking some magnets and coils together. There's a real method to the madness here, and the name carousel itself hints at something spinning around, right?
You got it. The real heart of the invention is this rotating carousel. Think of it like a platform carrying a bunch of magnets, and these magnets are moving right through the centers of the stationary coils. That's how they boost the voltage in the coils. It's not just magnets spinning around the outside, it's like they're going right through the core of the action.
Wow, so they're really bringing the magnetic field to the party, huh? Putting it right where it counts. If we were to sum up the whole invention, what would you say is the big idea?
Simply put, it's all about getting a ton of power out of a tiny generator. And the carousel mechanism is the key to making that happen. By moving those magnets right through the heart of the coils, they concentrate the magnetic field where it's needed most.
Got it. And that high power output is tied to the super fast spinning and high frequency, right?
Absolutely. They designed it to spin really fast, which creates that high frequency. That's what lets them squeeze so much juice out of a small design.
Now, one thing that really stood out to me was how the carousel is driven by magnets, not some mechanical connection. How does that even work?
That's one of the coolest things about this design. Imagine this. You have the rotor magnets spinning, and their magnetic field is pushing and pulling on the carousel magnets, making them spin too. No gears, no belts, just pure magnetic force. It's like a magnetic dance.
That's incredible. Less friction, less wear and tear genius. They also mentioned something about an air bearing for the carousel. Why an air bearing?
Imagine a cushion of air supporting the spinning carousel. That's an air bearing. It means practically zero friction, so it can spin like crazy without wearing down. Perfect for their high-speed, high-frequency goals.
Okay, so high speeds, magnetic drive, air bearing. This is getting pretty high tech. They also talk about high magnetic density without needing laminations. Usually, you need those laminated cores and generators to focus the magnetic field. How are they getting around that?
That's where their clever magnet arrangement really shines. They basically use the magnets themselves to shape and focus the magnetic field, kind of like a self-made magnetic lens. It's like they're creating a magnetic highway for those lines of force to travel along.
Okay, let's get into the nitty-gritty of the design. The patent has some drawings, and Figure 1 shows what the device looks like from the outside. It's a short cylinder with a shaft sticking out and a cable for the electrical output.
Yep. Then Figure 2 gives us a peek inside, showing a slice of the stator and rotor. They built their first version with 18 identical sections for the stator, each with a coil wrapped around a bobbin.
And what about the rotor? What's going on with the magnets there?
The rotor also has 18 sections to match. But here's the trick. Only 9 of them have magnets. 3 magnets per section, arranged in a specific way. And get this, all those magnets have their south poles facing out toward the coils. The other 9 sections are empty, and they alternate with the magnet sections.
So it's like magnet empty all around the rotor. What about the carousel and its magnets?
The carousel follows the same pattern, 9 sections with magnets, 9 empty. But instead of 3 magnets per section, it has 2, held tightly between special rings.
And this whole carousel sits inside the coils, right? There's mention of an air-bearing channel attached to the stator inside those coil bobbins.
Exactly. The carousel rests on this channel, and pressurized air creates that cushion I mentioned. It lets the carousel spin freely inside the coils on the same axis as the rotor, almost like it's floating on air.
And how do the rotor and carousel magnets work together? The patent says they're magnetically locked. What does that mean?
It means they're like dance partners, perfectly in sync. Each set of magnets on the rotor has a matching set on the carousel that it's attracted to. So as the rotor spins, it pulls the carousel along with it, all through magnetic forces.
That's so cool. No friction, no wear, just pure magnetic attraction keeping them moving together. The patent even gives exact dimensions for the magnets they used in their first prototype.
Yeah, they get into the details. Rotor magnets were 1 inch by 2 inches by half an inch, with the north and south poles on those bigger faces. Carousel magnets were 2 inches by 2 inches by half an inch, poles on the square face. They even named the supplier Magnet Sales and Manufacturing. That's some serious attention to detail.
It's great to see that level of detail in a patent. They also talk about the materials for the coil supports and other parts near those strong magnetic fields.
They specifically recommend Delrin or Teflon or similar non-conductive plastics. It's all about reducing those energy losses from eddy currents and keeping friction to a minimum. You don't want metals in there creating electrical drag and wasting energy.
So using non-metallic parts keeps everything running smoothly and efficiently. Now, how are those 2 magnets in each carousel section arranged?
Picture them standing upright, side by side, with their north poles facing each other about an inch apart. When the carousel locks onto the rotor magnets, the upper and lower rotor magnets are positioned right above and below that space between the carousel magnets, their south poles pointing in.
And where does the third rotor magnet fit in?
That one's called the inboard magnet, and it sits alongside the carousel magnets. It also has its south pole facing toward the carousel magnets. It's like they're creating a concentrated magnetic force field in that space.
They've definitely put a lot of thought into how those magnets interact. They mentioned placing the rotor magnets as close as possible to the carousel magnets, but still leaving enough space for the coils.
Yeah, it's a delicate balance. You want the strongest magnetic forces, but you can't have the parts rubbing against each other. That gap is critical for smooth operation.
Let's talk about how electricity is actually created in this design. The patent says voltage in the coils is proportional to the rate of change of magnetic flux linkages. What does that mean in plain English?
Think of magnetic flux, like invisible lines of force flowing from the magnets. When these lines pass through the coils, they induce a voltage. The more lines and the faster they change, the higher the voltage. What's interesting here is that each magnet in a carousel pair creates flux in the opposite direction through the coil.
Opposite direction. What effect does that have on the voltage?
It's like a tug-of-war. The voltage in the coil depends on the overall change in those flux linkages. When the coil is right between the 2 carousel magnets, their flux cancels each other out, so there's almost zero net flux.
Okay, so as the rotor turns, that balance starts to shift.
Right. As the rotor moves, the flux from one carousel magnet decreases while the flux from the other increases. This builds up net flux in one direction, creating a voltage with a certain polarity. As it keeps turning, the flux goes back to zero when the coil aligns with an empty rotor section. Then, as the next set of magnets comes around, the flux builds up again, but this time in the opposite direction, creating voltage with the opposite polarity. This keeps happening as the rotor spins.
So each coil sees a constant push and pull of magnetic flux, which creates an alternating current. And the faster the spin, the faster the change in flux, meaning higher frequency and possibly higher voltage too.
Exactly. That's electromagnetic induction in action. The voltage in the coil depends on how fast those flux linkages are changing, which is affected by both the magnet strength and the rotation speed. And because that change in flux goes back and forth, so does the voltage polarity, creating that AC current.
Now, the patent mentions that because of how the coils are arranged, neighboring coils experience these flux changes at slightly different times. This can lead to them having opposite polarities. How do they handle that when connecting multiple coils to get a usable output?
Great question. To make sure the voltages add up correctly, they have a couple of tricks up their sleeve. They can either physically install every other coil backwards or just reverse the wire connections on every other coil. Either way, it syncs up their polarities so they play nice together.
So it's all about getting those voltages aligned. But the patent also points out that even with that fix, there might be subtle differences in the voltage waveform from each coil because of slight asymmetries in the rotor's magnetic field.
That's right, and those tiny differences can cause problems. You connect coils with slightly different waveforms in parallel, you can get these unwanted currents circulating between them. It's like a little electrical whirlpool that wastes energy.
So they came up with specific ways to connect the coils to avoid that, right? Figure 8 shows a setup for high current, low voltage.
Exactly. In that configuration, all the even-numbered coils are connected in parallel, and all the odd-numbered coils are connected in parallel, forming two groups. Then, they connect these two groups in series, but flip the polarity of one group. This makes sure the voltages add up nicely and minimizes those pesky circulating currents.
And for low current, high voltage, Figure 9 shows a simple series connection for all the coils.
Yep, just make sure the polarity is corrected for every other coil, as we talked about before.
And for those in-between situations, Figure 10 shows a bunch of series parallel combinations. The key is to avoid connecting odd and even coils directly in parallel.
Right, the idea is to connect similar coils in series first to create a more consistent voltage, and then connect those groups in parallel. It reduces the chance of those waveform mismatches causing trouble.
So that covers the basic design with the 2 larger magnets per carousel section. They also tried a modified design with 3 smaller magnets arranged in a U-shape. Why the change?
It's all about getting a better match between the rotor and carousel magnets. Instead of 2 big magnets, they now have 3 smaller ones, arranged like a U, just like the 3 magnets on the rotor.
What benefits did that bring?
The patent says it creates a stronger and more reliable magnetic bond between the carousel and the rotor. Plus, those smaller magnets make the carousel lighter, which is great for high-speed spinning.
Lighter means less inertia, so it can spin faster and smoother. And they didn't stop there. Figure 14 shows another tweak with a 4th magnet added to the carousel, making a square shape.
Always pushing the boundaries. They added that 4th magnet and even suggested adding a matching one on the rotor to further refine the magnetic field and boost performance.
So all these tweaks to the magnets were about optimizing that magnetic interaction and making the whole thing run better at high speeds. Speaking of which, they really emphasize how well-suited this design is for high speeds and high-frequency output. What makes it so good in that realm?
They explain that at high speeds, the rapid changes in magnetic flux can compensate for weaker overall magnetic fields. Plus, that high-frequency output is perfect for certain applications, like fluorescent lights. They actually run better and can use smaller components with high-frequency AC power.
So it's not just about power, it's about matching the output to specific needs. And get this, they claim this device can also work as a motor. How does that work?
Think of it like running the generator in reverse. If you apply AC voltage to the output terminals and connect the shaft to a load, those coils create a changing magnetic field that interacts with the magnets on the rotor and carousel, making them spin. It's like switching the flow of energy.
So it's a two-way street for energy conversion. They even show how it can be used as a pulsed DC motor with some fancy electronics in Figure 15.
Yeah, for that setup, they need a sensor to track the rotor position, a programmable logic controller to make decisions, a power switching circuit to send those precisely timed pulses of DC voltage to the coils, and a potentiometer for the user to control the speed and torque.
So it's like giving the motor little electrical kicks at just the right time to keep it spinning smoothly and efficiently.
Exactly. The timing is critical, and they say each coil might only get a short burst of power during each rotation. And that potentiometer lets the user fine-tune the strength of those pulses, controlling the speed and power.
That's some next-level motor control. They also briefly mention using a commutator and brushes for motor operation, which is a more traditional approach.
Yep, that's a more mechanical way to switch the current direction in the coils as the rotor turns. It might not be as fancy as the pulsed DC system, but it could be simpler and more efficient in some cases.
Okay, we've explored the design and operation in detail. Now let's dive into those patent claims. What are the key takeaways from these claims for our listeners?
The core claim is all about a device that can convert between rotational motion and electrical energy. It's the big umbrella that covers their invention, which includes that stationary stator with the coils, the spinning rotor with magnets, and of course that unique spinning carousel with magnets that are magnetically locked to the rotor magnets.
And beyond that broad claim, what are some of the more specific things they're trying to protect with this patent?
They have separate claims for it being a generator and a motor, and they claim specific arrangements of those magnets, like having 2 magnets facing each other on the carousel, or 3 magnets on the rotor with their poles facing out. They even claim the housing that holds everything together.
What about the carousel itself? Any specific claims related to that?
Definitely. They claim those retainer rings that hold the carousel magnets, the use of an air bearing, and even the fact that they use an even number of coils.
And what about that clever way they manage the magnetic flux?
They claim that specific arrangement of the carousel magnets with their north poles facing each other, which shapes and focuses the magnetic field without needing bulky iron cores or laminations.
And those specific ways of connecting the coils we talked about.
Those are claimed too. They cover the parallel and series combinations for the odd and even coils, all those strategies for managing polarity and waveform differences. They also claim the number of magnets per carousel section, whether it's 2, 3, or 4.
And anything specific to the motor operation?
Yep, they claim using pulsed DC voltage for motor operation and the whole control system that goes with it, including the sensor, the controller, the power switching circuit, and even the potentiometer.
And lastly, what about the materials they use near those strong magnetic fields?
They claim using those non-conductive materials like Delrin or Teflon for any stationary parts near the magnets, making sure to minimize energy losses and keep everything running smoothly.
Wow, that's a pretty comprehensive set of claims. They're covering all their bases with this patent. So if we had to pick one key innovation from this whole carousel electric generator, what would it be?
It has to be that magnetically coupled carousel. It's the heart of the design, the thing that makes it so unique and efficient. It's all about that direct interaction between the magnets and the coils, and the ability to spin at those crazy speeds.
And it's amazing how they thought through all the challenges, like keeping it simple and reliable and dealing with those high-frequency quirks.
It's a testament to smart engineering, thinking outside the box, and coming up with something truly innovative.
So here's a final thought for all you listeners out there. Given what we've learned about this invention from 1997, how would you apply those same principles of magnetic coupling and clever magnet arrangements to design generators or motors today? Think about all the advancements we've made in materials and electronics since then. The possibilities are mind-boggling.
That's a great question to ponder. If you're intrigued by this Carousel electric generator, we encourage you to check out the full patent document online. Just search for US patent 5,625,241, and you'll find all the details and drawings. Or dive into some research on electric machine design. It's a fascinating field with tons of potential for innovation. Thanks for joining us for this deep dive.